And it is Monday, and we're coming to the end of the conference, and so if you don't know me by now, then you've done something wrong. Now, so, more seriously, Kiwi hands-on. That's really what I mean, hands-on. The idea here is that I have about 60 to 70 minutes of yakking, and the rest of the planned schedule is really for people to load whatever is on that stick and fiddle with it. Learning by doing. Okay, so what am I going to talk about? Introduction about me, which is basically the same that I had in my other talk. And then I'm going to talk what is Kiwi about. We'll look at prerequisites, install your image. I have my yakking to do, and then the plan would be that you fiddle with stuff, and then at the end we can talk about SUSE Studio, OBS, and integrated systems. Okay, introduction. That's me. I work in the ISV engineering team at SUSE. They bestowed on me the title of Public Cloud Architect. That means I fiddle with all the stuff where SUSE Linux Enterprise is in the public cloud, such as Amazon, HP, Google, Windows, Azure, and some others that we're working on. I am also the IBM Software Group Liaison. That means I work with the IBM Software Group to make sure everything operates properly in SUSE, and if they have questions, they know where to find me. Integrated systems means that I work with other people that write software that may run on top of SUSE, and the idea there is to build appliances, and that's where Kiwi comes into place. Basically, they bundle their application with the OS and then make that available to their customers. I contribute to Kiwi. Due to my cloudy things, has gotten a little less than I want it to be, but I write code, tests, documentation, I work on the architecture, so anything that a project needs. I contribute to openSUSE, maintaining packages. I happen to be a board member, and will run for re-election coming November. And I am passionate about motorcycling and soccer, so any day when it is nice and it's the weekend, you will not find me on IRC, because I will be out on the roads. Okay, what is Kiwi? Let's not go there just yet. Okay, so I recently read a book, and in that book it said, it is best to start at the beginning, at the very beginning. And this is why we will start in the middle. And we will start in the middle right, come on, click, click, here. Fingers on the keyboard. Okay. So, to do the workshop, you should be running openSUSE 13.1 on a reasonably new machine with virtual instruction set. You want to start a terminal session, log in as root, install libvirt packages, because you want to run network manage. You want to run virt manager. Install virt manager package, libvirt. Copy the stuff that's on the stick that I handed out onto your machine. I promise it's not going to damage your machine. Or you can install Kiwi directly on your machine if you want to work on your machine. That is fine too. But I prepared the sticks so that you wouldn't have to do that. I do need the sticks back, please. I promise to give them back because they are intended to go into booth boxes for marketing materials, so I'd like to give them back. And then when that's all done, then you just start libvirt. And that goes with system control, start libvirt d.service. Okay, then the next step would be you start virt manager, you connect to the local host, and then you create a virtual machine. Enter a name for the machine, Kiwi Lab for example. Select local install media, click forward, and then you would browse to wherever you copied this file, Kiwi Training Lab x86-64-110 install ISO, and then you click forward again. Select as much RAM as you can spare on your machine. So if you have a lot of RAM, then that's good. That may make the virtual machine run faster. You want to set up about 30 gigabytes of storage, and then you just use the virtual network default and click finish, and then Word Manager will do the magic network stuff behind your back, and you don't really have to know all the magic incantations to set that up yourself. Okay, and then after that, you can watch the magic happen, which means you will actually be installing an image that got built with Kiwi. So you will be running the lab on an image that got built with Kiwi while you're learning Kiwi. And that's that. And then in the VM, once the machine is installed, you can log in as root. The root password is Kiwi Lab, and start an XFCE terminal, and then you can, run ifconfig to find out the IP address of your virtual machine, and then you can just copy the ISO image into the virtual machine in this location, and then we will be ready to do the labs. And now we are ready to start at the beginning, at the very beginning, because that is the best place to start when you have a story to tell. And the story that I have to tell is that Kiwi is a wonderful tool. It's a fruit. We all know that. It is also a bird. That little guy there, that's a Kiwi bird. And as far as I know, it only exists in New Zealand, and the New Zealanders have the nickname of being Kiwis. Woohoo! Kiwi is also a Linux image build system. It is hosted on GitHub right there. GitHub.com openSUSE, license is GPL-v2, mostly written in Perl. There's also shellcode in there, and some utilities are C. The project itself is sponsored by SUSE, was started by Marcus Schaefer a while ago, and between Marcus and myself, we are the top contributors. Marcus is doing a lot more than I am, and sorry Marcus, I'll get back. And Kiwi is also backend of SUSE Studio, which you can find there, www.susestudio.com. SUSE Studio is a point and click way to use Kiwi. Kiwi itself is a command line tool. Okay, so if you want to point and click, use SUSE Studio. It's easy. If you're like me and you think a command line is the right way to interact with a computer, then Kiwi is the right tool for you. Most Kiwi commands require root privileges, quite simply because we need access to package management, user management, system configuration. So obviously those who are working the lab, you have a virtual machine, so when you mess that up, it's not that big of a deal. But if you run Kiwi on your system, you want to be careful, because rm-rf/ is a really bad thing to do. So, and you're root, and so you got to be careful. You can protect yourself by, building in a dedicated VM, which is what you will be doing here for the lab. Okay, other stuff. Documentation. There's a user's manual or cookbook that you can find on doc.opensuse.org. Projects Kiwi doc. That is always the latest and greatest, so that reflects the development tree status. And there is also a PDF of that thing, but that matches the version that you might install on your system. And that comes in the Kiwi doc package. Kiwi itself is in factory, it's in openSUSE 13.1, it's in SUSE Linux Enterprise. Then there are examples on the wiki, Portal Kiwi. They could use some love and care, but most of them still work. The configuration file schema is documented right there, also doc.opensuse.org. Then there's a mailing list, which is a Google group, Kiwi Images. You can subscribe there and send us mail. Or you can find us on IRC Freenode at openSUSE Kiwi channel. All right, so how does it work? This is what Kiwi does. It's a two-step process. In the first step, we prepare images. In the second step, which is the create step, we finish up the image, and then you get the result of whatever image type you're building. So it works in that we have the, and if I would know where the laser pointer is on this thing, then that would be good. Let's see, maybe this? Nope. This? Nope. Shows you how often I use it. Okay. I know there's a pointer on here. Anyway, so there's an image description, as you can see right there. That is a directory. And inside of the directory are a bunch of files. We look at one of those, which is an XML file. And in there you have the repositories configured. So between the stuff that's in the image description directory and the repository, you run Kiwi prepare, and out pops what we call an unpacked image tree. That unpacked image tree is basically a change root environment. So you can use it to change root into that environment, but any changes that you make in there will be overwritten the next time you run prepare, of course. So it is not recommended that you go in there and fiddle with stuff, okay? Everything that you want to fiddle with should always be from your image description. In the prepare step, we also copy the image description, or what we need from the image description, into the unpacked image tree. And so then when you create, basically we're looking at a copy of the image description, and we'll look at the unpacked image directory and we create the image. For certain image types, we need an init.ID, or most image types you need an init.ID. And the init.ID is a Kiwi created init.ID, which is a description, just like one that you create, but one that we created, so you don't have to worry about it. So the descriptions for the init.IDs come along with Kiwi, and in the create step we built the init.ID, basically following the same procedure. We stick it into the image, and then the image can be booted. Okay, what else? Yeah, so that's what I basically just went through. We read the configuration tree, we initialize the repositories, we install the packages, we apply overlay files, and what that means is I'll get to in a minute. We execute the shell script, which is called config.sh, and then we have the unpacked image tree, okay? And this is the generic command, kiwi -- prepare, the path to your configuration directory, and then -- root, a path to where you want that unpackaged image tree to live, okay? So, in the create step, Kiwi reads the information from the configuration tree, as I said. We access the unpackaged image tree, we execute images.sh, so another shell script where you can do custom stuff. We create the boot image, or init.ID, which is a description that Kiwi provides. Those descriptions are provided in Kiwi description star boot. So star means there are special descriptions for virtual machines, for OEM, and things like that. And what all those mean, I'll talk about in a minute. And then we create the final image. And the command line for that would be kiwi -- create path to the unpackaged image tree -d, and then a path where you would want the final image to show up. Okay. So let's take a look at what's in the configuration tree, okay? The configuration tree may contain these files. Config.xml must exist. Config.sh, images.sh, archives, and root are optional. And what they all are, we will talk about in detail through each one of those. Okay, so config.xml is required. That's the configuration file. Okay, as the extension indicates, it's an XML file. Woohoo! It has information in it about the repositories and about the packages that you want in your target image. Information about users you want to have set up in the system. Config.sh is a shell script that's executed at the root level of the target directory. So that gets copied into the unpacked image tree and then executed at the root level there. Okay, so you can put in there anything you want. Okay, you can, if you install Perl into your image, you can run a Perl script from there, or a Perl program, or Python, Ruby, or you can execute C code, whatever you want. Okay. So depending, of course, on what you installed.
So it will run under change root.
Excuse me?
It will run under change root.
Yes, it will run under change root. Okay. Images.sh is also optional. It's also shell script. That shell script gets executed at the beginning of the create step. So with Kiwi, what you can do is you can prepare an image once and then create multiple different types of target images from the same prepared root. So this may run multiple times. Okay, so when you write, if you write that, then you need to be aware that, well, once you copy something away or you remove it and then you run create again, whatever you removed is gone. It's not magically coming back. Okay, so you just have to be aware of that. Also executed at the root level. Okay, then archives. Archives are pretty much anything that we know. tar, tar-gc, tar-bzip2. What happens is that we take that archive and we copy it to the root tree, and then we unpackage it at the root level. So whatever is in there will clobber whatever you have installed through packages. Okay, so this is a great way to customize your image. If you already have existing firewall rules, for example, then you can take them and just put them in the tarball and stick them in there, and then they're just in your image. Okay, or other things, applications that are not packaged at RPM format, that have a non-interactive installer. You can stick them in there, copy them over, run the non-interactive installer, and then they're there where they belong. Okay, and then there is the root, which is a directory, and it is a reflection of the root tree in the target image. Okay, so this is a little complicated, but so the root tree in the target image is just like a regular root, the root file system, so slash, and this represents that file system. So anything that's in there gets copied verbatim into the target directory. So it's again another overlay mechanism. Here you would, for example, put network configuration stuff or something like that. I usually put that in the overlay tree, and then the network is configured. Okay.
What happened before or after the root is installed?
So we'll get to the order. Okay. What happens is that the tarball gets unpacked, then so you can play silly games there too with the tarball and the root tree and stuff like that. So, okay. The config.xml, as I said, is an XML file. It gets validated against the schema. It is also checked for consistency of the data. Okay, so if you're familiar with XML, the biggest quote-unquote problem with XML is that you can't do consistency checking. Okay, in the schema, there's no way for you to set up if-then-else conditions, and we have that. Okay, certain things don't make sense when they're put together, and so we have a consistency checker that runs, that is written in Perl, that reads the XML, and then it will complain and yell at you when there's an inconsistency in the data. Okay. The schema changes. Generally, we try not to break compatibility, and we use XSLT to automatically upgrade the the XML file. Unfortunately, we did have to break compatibility just recently when we were dealing with EC2, the way we built EC2 images. But that has been the only one so far over the years where we actually broke compatibility. The upgrade is automatic, but we don't change your file. So we upgrade it and we make a copy of your configured XML file. We automatically upgrade it and then we work on that. Okay, so now let's look what's in there. Okay, it's an XML file, as I said, woohoo! It starts with XML tag. Then we want you to give us the schema version against what you think your XML file should comply to. Okay, the current version of the schema I think is 6 something. Then you give us a name. Then we like you to tell us who you are. Basically we put that in so that nobody can commit any anonymous crimes. Put in your name and your contact and write a little something about what the image is for, okay? This is so your colleagues can find you and yell at you and say, hey, you created an image that doesn't work for me.
So I put your name in there, right?
No, because I only create images that work. So, that's about you. As you can see, the system, the description tag, has a type attribute that says system. Okay, this is what you create. There is also another value for type, which is what we use in the boot images. Generally, you don't have to worry about that. So when you're building something, you should always put system in there. And yes, if you're an advanced user and you think you have to create your own initrd, feel free. But if it doesn't work, don't call us. Okay, then the preferences element. It has a type element as a child, and this is where you specify what kind of image you're building, whether it's a VM or OEM image and so on. And what those are, we'll talk about in a little while. Then there's a version. You tell us the package manager you want to use, and obviously if you're building a SUSE image, then you would want to use Zipper, because it is the best package manager around. Yeah, then we generally turn off RPM signature check because the place that we're installing into, which is the target directory, does not have the keys of the repositories. And so if you don't turn that off, then, well, it will fail, okay? Then we forcefully install, and then you can set up the locale and your key table map. All right, next, what else? You need a user, okay? No user, no login. So you always want to configure the root user in the image. If you add any other users, that's of course up to you, but you need to have at least the root user. So you need to configure that. You give the password, and actually this has changed. It's no longer called PWD, it's called password. Then you have to give the home directory and the name. The password you can give in encrypted format, which is the default, or you can give it in plain text and then add another attribute to tell us that it's in plain text, and then Kiwi will encrypt it for you. Then you specify the repositories. That looks like that. So there are various types of repositories that are supported. So YAS2 is the repository type that you have on the ISO image. The repository types on download.opensuse.org or from the build service, they're all RPMMD types, metadata. So that's important for us to know. And then the next thing is you describe the sections of, in the next section you tell us what packages you want in the image. So from there it should be pretty straightforward. And at the bottom you tell us what packages you need to bootstrap the image, okay? So what happens is this bootstrap section tells us we want these two packages and their dependencies installed into the target directory. That means that happens from the package manager that is on your machine. And then after this section is complete, then we change root into the target and run the package manager that is inside of that directory, okay? So, the XML schema.
Question to package, what about the recommendations? Do they be installed or not? Dependencies.
There is on the packages type, there's an attribute that you can set to plus recommended or required only. So the default is plus no, the default is required only. Maybe it is plus recommended, I don't know. Anyway, there's a default that's documented, and but there's an attribute where you can control that. Okay, so the schema is written in relaxing, okay, compact notation. And we use that because there are some reasonably good validating parsers available for that. If you don't know anything about relaxing, you can learn something about it in these tutorials there. Then there's of course Wikipedia that tells you something about it. The schema itself is located right there. User share Kiwi modules Kiwi schema.rnc. So you can dig around in there if you wish and take a look. The schema is also documented. We automatically generate a web page where you can look at the schema. And it is installed as part of the Kiwi package because we need it so we can validate your XML. Okay. The parser itself generally is not all that useful. So if you have an error in your XML file, the messages that you get from the parser are most of the time relatively cryptic. There is a Jing tool, which is a Java tool. It produces nice output error messages, but it drags along the Java runtime environment. So if you hate Java, then you might just want to live with the not so nice messages from the parser. And if you don't mind having Java on your machine, then this is the way to go. Kiwi looks for Jing. If we find it, we'll use it to give you a good error message, and if we don't, then you just get the parser error message. Okay, image types. So now it becomes interesting. The image types, so Kiwi can build a ton of different images. The image is the type of the image is specified with the image attribute of the type element. Okay. And now I'm just going to go through all the image types. This is a rather long list, and I hope I won't put you to sleep while I'm going through that. So we'll start with Amazon. So Amazon EC2, Elastic Compute Cloud. So that's an image that's specific for Amazon. We support both S3 and EBS. So S3 is the simple storage service. That's an object storage implementation that Amazon offers, and you can actually have an image there and that you then can launch as an instance, okay? Things that are S3 based are not persistent. So when you start an image that is from the S3 storage, even if you install new packages and so on, if you stop the image, then all of that goes away. Okay. In EBS, which is Elastic Block Storage, that's more like a real computer, so the storage is persistent. When you fire up the instance and you install new packages and make changes, then those changes are persisted on disk, and as long as you don't delete. So if you terminate the image, then by default your storage goes away as well, so obviously then your changes are lost. But if you just stop the image instead of terminating it, and then your changes are persistent. So you also, whoa, this is old. Okay, so we no longer have an EC2 config element. We used to have that, where you give us the account number and then we can create the bundle for you, and we decided that we shouldn't really do that and people didn't like it. to have their account credentials in the Kiwi file, and so we just removed that options actually quite recently, and so obviously that's still in there. Okay, we require you will want to have an account for Amazon, of course, if you want to build such an image, so you can actually upload it and use it. And there is also no longer a requirement for DD Rescue because we changed the way we built the image. DD will do just fine. Okay, so you don't need that special tool anymore either. I obviously have to update my slide. Okay, so containers. Containers are all the rage. Docker, woohoo! And yeah, well, not really all that fancy. We've been building Linux containers in Kiwi for almost 2 years now when I implemented it, maybe longer, okay? A container is just a change root environment on steroids. It has access control and it uses control groups within the kernel to separate it from the rest of the system, okay? So Kiwi builds a Linux container, which basically is mostly the change root environment of the unpacked image tree. We wrap that up nicely for you in a tarball. We generate a configuration file that is reasonable, with reasonable permissions that we think is a good idea. And then we present that to you as a tarball. That tarball you would carry then, you can then carry to any machine where you want to run that container, unpack it at the root level, and Kiwi will put the container and the container configuration file in the correct places. And then you can run it. So the configuration file ends up in etc LXC, and the container ends up in varlib LXC, exactly where containers are expected to live. All right. OEM, what is an OEM image? An OEM image is what is on the stick, okay? It is a self-installing image that can be presented as an ISO or can be presented on a USB stick, okay? So basically I can make a USB stick that can plug into this machine, then boot from the stick, and then my image that I built will automatically install itself, okay? The way that works is that Kiwi builds a live image and wraps the image that you built, so the live image is wrapped around the image that you built, okay? The live image does the installation. During the installation, we expand the file system to take up the disk. If you want us to do that, there's a configuration for that. And then we do kexec, and then we're into that system that you built, okay? So that's an OEM image. Excuse me?
If I use the Open Build System appliances that you can download from ops, is that an OEM image?
Not necessarily. So some are, some aren't. It depends. The OBS. Yeah. So I think the OBS is an OEM. Is built as an OEM image, but you can build any image type within the build service, so it's just, you know, that's just the way Adrian set those up.
Yeah,
but there's no,
I just haven't used those appliances quite often. From when they boot the first time, it sounds familiar.
Yeah. So they're set up as an OEM image, that's correct, but that doesn't mean that you have to build OEM images inside the build service. So Kiwi is tied with the build service, but you can build any image type there. Yeah. Okay. Yeah. Right. Yeah. So the OBS build images are OEM images. Okay. And as I said, you can create a USB stick or CD, DVD. Okay. What else do we have? Kiwi supports to build network install images or Pixie boot. Okay. So you can create a Pixie image with Kiwi and then stick it on your Pixie server, and off you go. Nothing really magic about this here. What else do we have? Live images. Okay. Live images, such as our wonderful DVDs that we hand out, also built with Kiwi in the build service. Okay. All of our media is built with Kiwi. Not just openSUSE, but also SUSE Linux Enterprise. Everything is built with Kiwi. So we can build live ISOs, or you can build live USB sticks. Okay. What else? Then you can build virtual images. Of course, EC2 we already talked about. You can also build OVF, OVA, QCOW2, VMDK, VHD, VHD fixed, and raw images. Okay, those are all the virtual formats that are supported. And actually the trick here is that Kiwi always builds a raw disk image, and then we call QEMU image convert, and we get one of those out. Okay, so Kiwi doesn't really do any magic tricks here. We just use QEMU to get all these other things out. Okay, and in hopefully not too distant future, I'll get time to implement the Google stuff. Okay, what else do we have? We can build Zen images. We can build Zen hosts or guests. If you build a host, which means DOM0, okay, then you need to set special attributes. Boot profile attribute needs to be Zen. Your boot kernel needs to be ZenK. And you need to set the domain on Zen config to DOM0. Those are the magic incantations that you must have if you want to build a Zen host. Okay. By default, Kiwi will build a Zen guest. So if you just set the image to Zen, the image type to Zen, then you will get a guest image. Okay, that's not useful to run stuff on top. It's just a guest. Okay. Kiwi also generates the Zen config file if you're building a guest, but because we don't know what your virtual target environment is, if you have a Zen host, you will have to edit that to fix the path to the Zen image, okay? Because we don't know where it's going to live ultimately. All right, now let's talk about config.sh. That's a shell script, and it is executed at the root level of the unpacked image tree at the end, okay? At the very end of the prepare step. So anything that you packed in your tarball or in your overlay tree can be accessed from config.sh. Okay, so if you have, as I said earlier, if you have an application that is not in RPM format, but has a non-interactive installer, you can stick that in the tarball and then can call the installer from config.sh, okay, because that tarball gets unpacked earlier. Then there are certain functions available to modify and customize the image. So for example, we have a SUSE system service enable or something like that. That's a function that works with sys5 init and systemd. So you just tell us the name of whatever you want to enable, for example sshd, and then Kiwi will do the right thing, whether it's a systemd file or system5 init. Okay, so currently in SUSE Linux Enterprise 11, there's still system5 as the init system, and of course in openSUSE we switched over to systemd. If you exit from there with a non-zero exit status, then Kiwi will generate a build failure. Okay, so when you put stuff into that file, check your exit codes and then return appropriately. So this is what it looks like. At the beginning, you will source Kiwi config, so .k config and .profile. These create the functions and variables that you can then use inside your shell script. And then this is what it looks like to activate services. So there's a list of default services, and then SUSE insert service in this case would be boot.deviceMapper. But as I said, so this could then be SSHD or Apache or MySQL, you know, whatever service you want to start. So that is actually relatively straightforward. Okay. Then as far as configuration is concerned, so for example here we have a function that's called base update sysconfig. So you tell us what file you want to change, what the variable is, and what the value should be, and then Kiwi will do that. Okay. And then obviously in SUSE config itself has gone away. So there's a function in Kiwi that's called SUSE config as well, and that abstracts that as well. Okay, so in openSUSE we also used to have a SUSE config command, as we still have as in /11, but that's now gone away. So in openSUSE 13.1 and I think 12.3 already, SUSE config was on its way out. And so that function basically abstracts it away for you, and you don't have to worry about if I'm building 13.1 then I want it, and if I'm not then I don't want it. So you can just call that function. And then at the end you would clean up, and again exit 0, and then Kiwi will continue. What's next? Images.sh. Okay, so images.sh is executed at the top level of the root of the target tree when we run create. So this happens very early on. Images.sh is a great way for you to, let's say, fiddle with kernel drivers. So if you're building an image for a certain target, let's say you're building a virtual image, you may not need telephony or ISDN drivers or whatever stuff is in the kernel still these days, right? So in images.sh you can clean that up if you want to cut down on the size of your image. Again, non-zero exit status triggers a Kiwi build failure, okay? But as I mentioned earlier, be aware, if you create multiple images from the same root tree, this script will be executed multiple times, okay? And so if you're building an OEM image where you do want an ISDN driver in, and you're building a virtual image with the same packages and you don't want the ISDN driver in, so if you remove it in one and then you build the other one, it's going to be gone there as well. So just keep that in mind. Okay, and now we are where we started. Fingers on the keyboard. Didn't work for you? You gave up. It's okay.
Anybody up for pair programming? What do you have in your machine?
No, he's,
2 gigs memory.
yeah, that's not gonna do it. So
I'm having network issues and can't get anything installed, so
okay.
Zipper's being extraordinarily slow for me.
Okay. All right. So I guess then we are pretty much at the end.
Why does it need so much memory?
Hmm?
Why does it need so much memory? In 2 gigs I can run at least 4 instances.
So this is just
minimum
right.
command line stuff. Why does it need memory?
Well, so in this case, I gave you a virtual machine.
Yeah.
So Kiwi itself doesn't need a lot of memory.
Yeah, but virtual machine doesn't really.
Okay.
I can run openSUSE, I'm not sure, but I run virtual machine with 368.
Yeah.
Not sure whether I can do that with openSUSE, but I'm quite sure I can do it with 512. So where's the problem? This machine needs, if we shut down X, which we don't need.
Well, this virtual machine that I prepared does run X. It has XFC in it, which is relatively small. But I would say you want to run a gig. You probably want to run a gig for that virtual machine. Yeah. So within a gig, it may work, but it would be slow. Anyway, so let's just go through the related topics. So there's SUSE Studio. It's hosted at SUSEstudio.com. It's also available as a product that you can then run behind your firewall if you care to. It's a web app, so it's point and click. It's written in Ruby it uses Ruby on Rails framework. Kiwi is the backend image builder. What happens there is within Studio we have what we call as a containment. So that's a prepared virtual machine, very similar to what I have set up there. But of course they don't have XFC. And what they do is they fire up the virtual machine, they inject the Kiwi configuration into that virtual machine, and then they kick off a Kiwi build. Okay. The web interface does not support all the features that Kiwi does in the configuration file. Okay, very simply, the web interface is targeted for quick and simple. You go through and then you have your image. Okay, so for example, in Kiwi, you can use pretty much any file system type for your images that we support in openSUSE or SUSE Linux Enterprise. With Studio, you can only build ext3 file system images, for example, at this point. Okay, so it's not complete, feature complete compared to Kiwi, but that's not the goal either. Okay, so if there's something in if you want to use Studio and there's something missing that you think we definitely have to have, you can file a request and that will be considered. But feature completeness is not the goal of SUSE Studio. Okay, then we have the openSUSE build service, or the open build service. Build.opensuse.org is an instance of OBS. You can find Kiwi there and all the packages that make up openSUSE. Kiwi is fully integrated in OBS, so that means you can build Kiwi images inside of OBS, and the OBS images are built with Kiwi in OBS. Okay, and so the public cloud images that we have for openSUSE, for example, are also built in OBS. There are a few quirks in the configuration file when you build in OBS. It's not necessarily for the faint of heart, because there are a few things that you have to consider, but it is possible and it can be learned. Even I'm learning. Okay, what is an appliance? Appliances are basically images that is an OS and an application, and that a vendor, an ISV, somebody else can basically give to their customer, and it's finished. Then the customer doesn't have to struggle with installation of the application. They don't have to struggle through to any tuning if that needs to be done, and then it just, it just works. Generally, there are studies that most application support calls are installation related, something on the order of 60 or 70%, which is quite crazy. So ISVs that go that route can cut down on their support calls by quite a good chunk. All right, quick summary. Okay, Kiwi is a very flexible image build tool. It is command line driven, easy to integrate in existing build processes. So if you build an application and you want to make an appliance out of that, at the end of your build process, you just type in Kiwi prepare and Kiwi create, and then you're done. Okay, and we support many image formats. GPL MB2 is the license. The mailing list is Kiwi images, and you can find, for the most part, you can find Marcus and me hanging out on openSUSE Kiwi IRC free node. And with that, thank you very much, and sorry the building didn't work. So, and if you have any questions, please feel free.
Hi, where can we find the lab and documentation with steps to try at home? This lab.
You can check file is recorded. Did you copy the files?
Yes.
So you have the files, right? And the lab is everything is recorded. So you can go to youtube.opensuse TV, and then you can watch me again and again and again and again. Okay? So, anything else? Other questions? All right then. And we're done already. Thank you. You're relieved? The conference is at the end.